So we're going to pick up where we left off on exercise 1. We're ready to try to sketch a graph of this equation. We're at part G. And on this separate sheet, what I did was I wrote down the coordinates of all the points we found so far. We found the x-intercepts, y-intercepts, and a few other points. And so let's try to see if we can sketch a graph. And let's see here. I have 1, 0. So x is 1, y is 0. Negative 1, 0. I have 0, negative 1 on the y-axis. I have 3, 2. 1, 2, 3, 2. I have negative 3, 2. I have 2 cube root of 3. Now I have to approximate its location. I mean, I can probably only guess about one decimal place, so I'll say 2, 1.4, 2, 1.4, so just a little less than halfway up a square. And then I have negative 2, 1.4. And from those points, I'm going to make a guess about the shape of the graph. I'm going to use pencil here because I don't really, all I have are these points. We have quite a few to go on. I mean, I would guess something kind of V-shaped, kind of like that. And I think that's a perfectly good guess to make from what we figured out so far. And it's not right. It's wrong. I'm going to summon Desmos to help me out here. So Desmos is a free graphing calculator app that I think everybody should have on their phones. It's free, and it's great, and it's very intuitive. I actually have it on my tablet here. And notice that I typed in the actual equation, x squared equals y cubed plus 1. So if you have any questions about using Desmos, just let me know, because it's intuitive, but it's not always obvious how to do things. And here's what the graph looks like. All right, that's exactly. It's really got this U shape before it takes off like bird's wings on each side. And I would have never guessed that. I think I would have had to plot an awful lot more of this graph to ever see that. It kind of does a thing like that. And on this side, it does a thing. So don't worry about not being able to see the shape of this graph. I just want you to be aware that we can be surprised, that it's not obvious what graphs are going to turn out to be, even though we had a lot of points plotted. I guess I could do that a little bit neater there. There we go. And we want to make one observation about this graph before we move on. It has a certain kind of symmetry. It has y-axis symmetry, we say. If I fold this graph along the y-axis, the two halves match up exactly. There's a certain bilateral symmetry here. And graphs that have this symmetry actually we can often recognize it just from the equation. We can see the symmetry in the equation before we even plot points. And I draw another picture here. This is a different graph. This is another graph that has y-axis symmetry, where if I fold along the y-axis, the two halves of the graph match together exactly. And algebraically, what symmetry, y-axis symmetry means is if you have xy on the graph, then negative xy is also on the graph. A point with a negative x coordinate and same y coordinate must be on there. That corresponds to 2 points that would come together when you fold along the y-axis. And because of this relationship between xy and negative xy, to test an equation for y-axis symmetry, what we can do is we can replace x with negative x in the equation and see if an equivalent equation results. And that's actually on our handout, and that's the point of exercise 2. So let's go ahead and do exercise 2. So we're working with this same Same equation, still x squared equals y cubed plus 1. And now we know this equation has y-axis symmetry, at least we strongly suspect it does, so this test should work. The test is really more useful when you don't know what the graph looks like for an equation, and so this helps us understand where we're headed when we're plotting points. So let's go ahead and apply the test where we replace x with minus x. So we get minus x. Now we have to write minus x in parentheses squared, because that whole quantity will get squared. And then what we do is we simplify. And I think you know that when you have negative quantity minus quantity squared, it's the same as, in this case, just x squared, right? Negative times negative is positive. The minus signs cancel out there. And so we get our original equation. So yes, the graph does have y-axis symmetry. And so we've finished exercise 2. Now in the next video we'll continue on with this handout in exercise 3.